In 5th grade, my teacher offered me a deal, and he said that I would never have to do any homework if I paid him a penny on the first day. But there was a catch. On the second day, I had to double the amount that I paid him on the first day, so I would have to pay him 2 pennies. And then on the third day, it'd be 4 pennies. And on the fourth day, it would be 8 pennies. Then 16, 32, 64, and 128. And all of a sudden, I started to see a pattern when I was thinking about these numbers. They were getting really big, really fast. And so I thought ahead and go, well, if I waited 30 days, how many pennies would I owe my teacher? It'd be 536,870,912. And I was very lucky that I didn't have to pay him that because I understood exponents, which is what we're going to be talking about today. So what we have right here is we have 3 to the 4th power, okay? The 3 is what we call the base. The 4 is what we call the power, or it's also called the exponent. So this would be 3 to the 4th power. And what that means is that the power is the number of times you multiply the base times itself. So the power is like a counter. So in this case, we are going to have 4 of the number 3. So you have 3 times 3 times 3 times 3. Well, 3 times 3 is 9. Then times 3 again. That becomes 27 times 3, which is equal to our answer of 81. So 3 to the 4th power is equal to the number 81. And so in our problem that we were talking about right away, each of these number of days can be an exponent for our problem. And since we are doubling, it would be 2 to the something power if I wanted to know the number of days. Okay, so that is what we're learning about today with exponents. So let's do a few quick examples. So the first one we did before, which is 3 to the 4th, which is 3 times 3 times 3 times 3, 4 times, okay? A very common mistake is people do 3 times 4, which is equal to 12. And that is not correct. In fact, if you bring up to your teacher right now and show them that 3 to the 4th power is equal to 3 times 3 times 3 times 3, 4 times, and it is not equal to 3 times 4, you can get some of your classroom currency. Let's do a couple quick examples again. 2 to the 3rd power is equal to 2 times 2 times 2, 3 times because of our exponent. 2 times 2 is 4. 4 times 2 again is 8. And for our last problem, 5 squared is equal to 5 times 5. So 2 5s, and 5 times 5 is equal to 25. Now, there's one concept in exponents that can be a little bit tricky if you're not careful, and it's called the 0 power or the 0th power. So 3 to the 4th power, we've actually done in this video a lot already. That is equal to 81. Okay? Now 3 to the 3rd power, so 1 less power, is 3 times 3 times 3, which is 27. Now, what you might not have noticed is from 81 to 27, we are dividing by 3 because there is 1 less 3 involved. If I do 3 squared, that's 3 times 3, or 9. From 27 to 9, once again, we are dividing by 3. There's 1 less 3 involved. 3 to the 1st power is just 3. Once again, from 9 to 3, we are dividing by 3. Therefore, 3 to the 0th power is not 0. Because from 3 to the answer, we have to divide by 3. 3 divided by 3 is 1, not 0. Therefore, anything raised to the 0th power is 1, not 0. There is one small exception, and that is 0 raised to the 0th power. And that is a skill that we'll talk about as you get a little bit older. I know that Mr. Schmidt brings it up in his 7th and 8th grade classes when they start to get into more complicated exponents. But for now, anything raised to the 0th power is 1, not 0, except for 0 raised to the 0th power, which is impossible. So fractions and decimals also work as well. So if we have our base of 1/2 and our exponent of 3, that means we are doing 1/2 3 times, multiplied times itself. 1/2 times 1/2 times 1/2. 1/2 times 1/2 is 1/4. Times 1/2 again for our third one is 1/8. So it looks like it's a lot harder, but it's actually the same to do 1/2 times 1/2 times 1/2, or 1/2 to the 3rd power. Now, the decimals also work the same, so it's 5/10 to the 4th power is 5/10 times 5/10 times 5/10 times 5/10. This can get a little bit trickier when you are multiplying, because 5/10 times 5/10 is 25/100. Now, another trick you can do is I can do 5/10 times 5/10 over here and get 25/100. And now I have to multiply them together. And we're going to do 4 digits left behind the decimal place. Oops, what am I doing? There we go. 0 and 5. So that would be 625 with 4 digits behind the decimal place. Right there. To give me 625 10,000. So that's one's pretty tough, which is one of the reasons why exponents are nice for decimals, that it can end up not getting too difficult or crazy, depending on the problem. Let's do 2 more quick examples. I want you to try these on your own. I'm going to pause the video and put the answers in for you. Our first problem ended up being the answer of 4/9. So we did 2 times 2 is 4, 3 times 3 is 9. You also notice that if I did 2 squared is 4, 3 squared is 9. I want you to try the last problem over here. Our last problem was actually quite difficult because of the number of digits that ended up behind the decimal point. And if you want a few more examples on how to do those decimal problems quicker with exponents, that will be in the retake video. As always, if you have any questions, please let me know.